So hello everyone, in this video we are going to discuss the problem E of today's contest, which is data structure fan. We are given an array of integers and we are also given a string S, a binary string, and we are given some queries. In each query we are given, there are two type of queries. The first query is of the type LR, where we have to invert all the indices where I belongs to L to R, and the second query is of type G, where G belongs to 0 or 1, and we have to find the bitwise XOR of all the elements A of I, where S of I equal to G. So I hope you understand the question well. Let us move on to the coding part. So let us take one particular example, this. So we have this example with us. Before moving on to the solution, let us see how we can approach the problem. So let us suppose this is the set and this is the set. This set contains all the elements which are having zeros in the binary string, and this set will contain all the ones, just like this particular string, which is 0 0 1 0 0 and 1. The indices are 1 2 3 4 5 6 7. Now we know that the for indices 3 and 6, they are having 1 in its representation of the string S, and 3 and 4 are, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So 3 and 6 are the 14 and 5. So in ones we will add 14 and 5. The rest element, that is 12 12 14, 12 12 14 we have already taken 14, and this 5, remaining is 14 and 5. So this will be in another set. Now let us suppose we are having the bitwise XOR of all the elements in this particular variable, and bitwise of all the elements in ones in this particular variable. This is suppose Z and this is O. So O will contain bitwise XOR of all the elements which contain 0 in its binary representation, and likewise for O it will contain bitwise XOR of all the element which contain ones in the binary representation of S. So now we know that we can directly calculate the query of type 2. So if it is asking 1, we can simply return this particular variable, because this contain the bitwise XOR of all the elements, and if it was 2 0, we will return this particular variable. This will contain bitwise XOR of all the elements. This is not set, this is a variable only. Now the major question is that how we can find, or how we can invert all the elements between 2 and 4. Now in this query we have to invert all the elements between 2 and 4. So this is the major question. So the main observation or main thing is that, suppose we know that in the zeros we are having v of 0, v of 1, v of 1, v of 2, v of 4, and v of 5. Now we want to invert all the elements 2 to 3, that is all the elements between 2 and 4. This is these two elements 2 and 4 should be shifted to this particular set, and 3 should be shifted to this particular set. Okay, that is clear. So in the set zeros we are having the elements of indices 0, 2, 4 and 5. So, and we are having query 2 to 4. So is there any way by which we can delete all the elements 2 to 4 and insert an element which is not present in this particular segment? So what we can do, we can take XOR of all the elements. We know the XOR of all the elements, which is 0 XOR 2 XOR 4 XOR 5. Now we know the XOR of 2 to 4, that is 2 3 4. If we XOR this particular element or this particular variable with this, so we will get what we want, that is 0 3 and 5. The 2 and 4 will be get erased because it is occurring twice, and 3 is occurring once, so it will be inserted. This is actually what we want. So for every query, if we want to invert all the places between L to R, between the set, it is the set containing zeros, it is ones. So we will be having a vector pre that will contain pre of I will denote the XOR of all the elements till ith position. Okay, so how it will gonna help? So if we are given a query like this, that is if we want to remove all the elements from 2 to 4, we will XOR all the elements between 2 to 4 with this particular variable. By this, all the elements between 2 and 4 will be removed and the element 3 will get inserted. Similarly for 3, if we know that for ones it is having indices 3 and 4, 3 and 6. Now we have to insert indice 2 and 4 here. So what we can do, we can have XOR of two to 4, and when this XOR is XORed with this particular O variable, we will get a new set which will be containing 2, 4 and 6. This is exactly what we want. So we have to pre-compute a pre-vector which will contain all the XOR of elements till ith position, and if we want XOR of I to j, so this will be pre of j XOR pre of j minus 1, I minus 1. So why this is true? Because pre of j will be, let us take pre of j is nothing but XOR of array of 0 XOR array of 1 XOR array of 2 till array of j. When we will XOR it I minus 1, I is less than j, so P of I is array of 0 XOR array of 1 XOR array of 2 till XOR array of I minus 1. So when we will XOR both the element, we will be having array of I XOR array of I plus 1 till array of j. So we having all the XORs from I to j. So this is the particular implementation I will be showing to you. I have taken input and taken string and created a vector which will be storing XOR of first ith element, and I have created two variables, zeros and ones. Initially I have set zeros to 1. Zeros will be having the XOR of all the elements where si is 0, and ones will be containing XOR of all the elements where s of I equal to 1. Now if query is 2, we know that if g is 1, the ones will contain XOR of all the elements and 0 will contain XOR of all the zeros elements. So we will output this. Now the interesting case is here that if we are given L to R, so we will be finding the XOR of L to R, and then we will be exchanging all the elements which 0 contain and 1's contain. So this is the particular case for exchanging the indices, where or inverting the bits in the string and give the exchange the indices between them. I have discussed how it is happening here. So it is exchanging all the indices by this particular XORing. So I hope you like the video. Thank you so much.